Welcome to today's Explainer. We are taking a deep dive into the fascinating, incredibly high-stakes world of heavy hauling. You know, when most people see a dump truck rolling down the highway, they just see a big truck moving dirt. But as we're about to see, these machines are highly specialized, precision-engineered tools. They are literally the backbone of construction, mining, and civil engineering. And whether you're moving raw materials or hauling away massive amounts of demolition waste, understanding the logic behind these vehicles, it completely changes how you look at a job site.
Because getting that logic wrong has extreme financial and logistical consequences. If a project planner chooses an undersized truck, the entire project suffers from costly delays and agonizingly slow material flow. But if they overcompensate and bring in an oversized truck, there's a good chance they're burning through wasted fuel, risking severe structural damage to the site itself and severely cutting into their operating margins. In this industry, precision is absolutely everything.
So here is our roadmap for today. 1. What is a dump truck? 2. Meet the truck fleet. 3. Sizing and payload capacities. 4. Steel versus aluminum bodies. 5. How hydraulic systems work. And 6. Choosing your perfect match.
All right, kicking things off with Section 1. What is a dump truck? The heavy-duty backbone.
To establish what actually separates these heavy-duty behemoths from your standard commercial cargo trucks, it really all comes down to autonomy. They are specifically engineered to load, transport, and, most importantly, discharge high-density materials, stuff like crushed stone, asphalt, and heavy soil, super quickly and without needing a second piece of equipment on site just to unload them. That autonomous hydraulic unloading makes them completely indispensable for large-scale earth moving.
Moving right along to Section 2, meet the truck fleet beyond the standard chassis. Because dump trucks are absolutely not built with a one-size-fits-all design, the chassis configuration you choose directly dictates your job site efficiency. What's incredible here is just the sheer variety of configurations based on the environment. You've got your standard trucks for highway use and tight construction areas, but then you have transfer trucks pulling a separate trailer box that actually rolls right into the main bed, which maximizes payload while keeping maneuverability. You have side dumps that tilt their cargo laterally to the left or right. Road building crews absolutely love these because they prevent tip-overs while they're laying continuous rows of gravel along a highway shoulder. And then there are super dumps, which drop down a trailing axle to spread out weight and maximize legal highway payload.
But I really want to highlight a standout here, the articulated dump truck, or ADT. Unlike a rigid truck, the ADT features a specialized pivot hinge right between the cab and the dump box. This joint allows the truck to independently articulate, maintaining all-wheel drive traction and steering control on heavily uneven ground and thick, deep mud. Honestly, if you're running a massive civil engineering project or an open-pit mine, this off-road capability is a total game-changer.
That brings us to Section 3. Sizing and payload capacities. The volume versus weight paradox.
This leads us right into the most common and frankly the most costly mistake project managers make when estimating payloads. How much material can a dump truck actually carry? It seems like a simple math problem, doesn't it? Just look at the size of the box and fill it up to the brim. But the reality of heavy hauling is so much more complex than that.
So, the crucial point you've got to understand is the difference between volume, which is measured in cubic yards, and weight, measured in tonnage. If you are hauling a lightweight material like topsoil or mulch, you're going to fill up the physical space, the volume, very fast. But if you are hauling dense materials like wet sand or gravel, you are going to hit your legal weight limit way before the bed is physically full. You might be driving down the highway with a bed that literally looks half empty, but if you add even one more scoop of wet sand, you are suddenly violating federal weight laws.
And this brilliantly illustrates the massive scale we are talking about here. Over on the light-duty side, we have Class 3 trucks carrying 1 to 3 tons for residential landscaping, but follow that all the way down to the off-highway rigid trucks used in open-pit mining. These 400-ton Leviathans are literally the size of a 2-story house. They require dedicated haul roads because they would instantly crush public infrastructure. It is just an incredible spectrum of engineering.
For those heavy-duty trucks operating on public roads, they have to contend with strict federal bridge laws that regulate weight distribution across commercial axles. Exceeding these causes massive structural road damage, not to mention brutal fines. This is exactly why you'll often see trucks using tri-dam, quad, or drop axles. By dropping an extra axle down onto the pavement, the truck effectively spreads its heavy payload weight over a larger surface area, legally complying with bridge formulas without sacrificing any of that material volume.
All right, Section 4. Steel versus aluminum bodies. Choosing your armor.
This is where fleet managers really have to balance raw durability against maximizing their legal payload capacity. The choice of materials drastically alters the truck's operational life. High-tensile steel provides superior impact and abrasion resistance. If you are hauling heavy concrete slabs, large rocks, or demolition debris, steel is absolutely mandatory to prevent a catastrophic body failure. Structural aluminum, on the other hand, weighs significantly less, and that weight reduction translates directly into allowing you to legally carry more payload per trip. However, aluminum will deform under heavy impact, so operators smartly reserve those aluminum bodies strictly for non-abrasive materials like fine gravel and sand.
Moving to Section 5, how hydraulic systems work, the mechanics of unloading.
We've talked about the box and the wheels, but now let's explore the mechanical engineering that actually lifts tons of material into the air. Let's see how this builds step by step. First, the operator engages the power takeoff, or PTO unit. This brilliant device connects the truck's transmission directly to a hydraulic pump. Second, that pump pressurizes hydraulic fluid. Third, that immense pressure forces a massive telescopic cylinder to extend outward in stages, lifting the front of the heavy cargo box. And finally, physics takes over and gravity pulls the loose material out the rear tailgate. It's a beautifully simple flow of power translating into thousands of pounds of lifting force. But a quick side note here, overloading the box can exceed those hydraulic pressure limits, causing severe structural failure. So that payload math we discussed earlier, it's also a major matter of safety.
And finally, Section 6, choosing your perfect match, synthesizing the data.
So how do fleet planners actually synthesize all this data to make the right call for their job site? Well, it comes down to balancing 4 essential factors. First, what is the material? Because an abrasive rock requires a steel bed, while light mulch can easily use an aluminum one. Second, what's the terrain? Paved roads allow for a standard chassis, while deep mud demands an articulated dump truck. Third, what are the payload needs? You have to balance the physical volume with those legal weight limits. And finally, operating costs. Balancing these exact factors prevents incredibly inefficient transportation cycles and ensures you aren't burning excess fuel or wearing down expensive tires needlessly.
The source material summarizes this entire philosophy with a really perfect quote. The most expensive truck is not always the most efficient choice. Buying a massive 40-ton rigid off-highway truck for a residential commercial build isn't a flex, it's a massive liability. Precision beats raw spending every single time. It's all about matching the exact machine to the exact operational requirement.
So, I'll leave you with this final, provocative thought to take away from this explainer today. Look at your logistics, look at your next project, and ask yourself, are you paying for space you can't legally fill? Or are you underestimating the rugged terrain of your next job site? Understanding the true capabilities and limits of these dump trucks is the ultimate key to heavy hauling success. Thanks for joining me on this deep dive into the engineering and strategy of heavy logistics, and keep analyzing the incredible machines that build our world.